Hello coders, Synthetic Programming here with another video for you guys today, and today we are going to be programming a viral spread simulator in Python. So this video is called Simulating COVID-19. It could be another virus. Again, when you mess with the parameters, it could really be any virus that's spreading. And really, we're not going to use the scientifically accurate COVID-19 data values because they're so all over the place. So many different sources have different ideas of how quickly the virus spreads. So we're just going to program like a general virus simulator in Python and look at the data that it can produce. And then you guys can tweak those values and mess with it, and maybe you'll learn something cool about immunology and the spread of viruses. Before we get started, please remember to rate, comment, and subscribe if you are interested in seeing more stuff like this. I program all the time and I post videos about it every once in a while, so if you're interested in seeing those videos, please hit subscribe and then maybe hit that notification bell so you get a little ding every time I post one of these videos. So without further ado, let's get into programming a viral spread simulator in Python. To get started, we are going to have to do a couple imports. The first thing we're going to import is random. So from random, we're going to import two functions from here for random number generation. We're going to do random and randint. So random generates a random number between 0 and 1. Randint generates a random integer between a set of integers. We're also going to need some plotting stuff for showing the data. So from matplotlib, import pyplot as plt, just like that. Awesome. So the next thing that we are going to do is we are going to make two classes. Now the two classes we're going to make is a class for a person, so like a person object, and then a building object. So the class for person is going to look like that, and we're going to do def init so we can start the class, just like that. And here we're going to initiate the person with a status. And the status can be one of four things, but we're going to get to that later. So self.status, just like that, is going to equal status. And then we also have to set two other variables for this object. So the next thing is self.time sick. So if they get sick, how long have they been sick for? That's going to be 0, because when the person starts off, they're not going to be sick for any amount of days when the simulation starts. The next thing we're going to do is say self.building, just like that, and self.building is going to be equal to just like an empty list, just like that. Awesome, and that's our person class. Super simple. So the next thing we're going to do is we are going to create a class for a building. So class for building is going to have an initialization function of def init, just like that. And all we're going to give it is a building ID. Are we going to use this ID? No, not really, but it's cool to have just because we want to keep track of maybe what building later that the person is going into. So again, not going to use it here, but again, having that variable there is useful, so maybe people can expand on this. The other thing we're going to do is say self.building ID. It's just equal to that building ID that we pass in. And the other thing we're going to do is we are going to say self.num sick. So the number of sick people inside the building is going to be equal to 0 to start when you make the building. Nice. Okay, so now we can actually start writing our simulation function. And this is going to be the longer function. So let's start off with def simulate. So this is our simulation function, and we're going to start with a couple things to run our simulation. First, we're going to have a certain number of buildings. So we're going to call that n buildings, just like that, right? Next thing we're going to have is the number of healthy people. And then we're going to have the number of sick people. So we're just going to call that n sick. And then we're going to have the iterations. Or we can also call this days. So days, just like that, right? And so here what we're going to do is we are going to start off by making our town. So the town is going to be equal to a list of buildings. And remember, we made this building object, so we can just say building I, which means that the building will have the ID I for I in range, and the range is going to be n buildings, just like that. So this is going to be our whole town. It's a list of building objects, and each ID is just 0 through the amount of buildings that we want to have in our town. So we got that done. Nice. Next thing we're going to do is set up the people in our town. And the people in our town is going to be equal to a list of person objects. And the list of person objects is going to have, let's see, we want to give them a status of healthy, just like that. And that's going to be for I in range and then n healthy, just like that. So the number of healthy people. But that's not all the people that are in our town. We also have people who are sick. And so we're going to add another list to that. We're going to concatenate the list. So we're going to add a list of person objects who are sick. That's going to be their status. So again, these are two of the statuses, healthy and sick. And we're going to say for I in range, let's see, for I in range and sick. Just like that. And now we're going to just make it look a little nicer by doing that. So, okay, we have our people now. So this is going to be a list of all the people in our town. We have the people who are healthy, and we have the people who are sick. We add those lists together, and now what we have is a list of everybody in our town. We start with healthy people and sick people. So the next thing we're going to do is set some variables for tracking the data. So the healthy, like that. Healthy history is going to be equal to a list, and in the list we're just going to put the number of healthy people because that's the first day. At day 0, there's the amount of healthy people that we set. We're also going to say the sick history, just like that. And that's going to be equal to a list with n sick, because we know how many sick people we're starting with at day 0. Now there's 2 more things that people can be, right? There's 2 more statuses. You can either be healthy, you can be sick, you can be recovered, or you can be dead. So let's do recovered. Recovered history is going to be equal to a list with just 0 in it, because on the first day, 0 people have recovered. And then we're going to do dead history, just like that. So the amount of people who are dead on day 0 is 0. So we start with some healthy people and some sick people. No people have recovered yet. No people have died yet. So now we have that. And then the last thing we're going to do is days, just like this. And days is going to be equal to, here actually, we're going to say, we'll call this iterations up here just so we don't get like a naming issue. So we're going to call this iterations, but it's really just the amount of days. But days is going to be a list. Day for day in range iterations, just like that. Perfect. Okay, so now we're going to actually start the loop of our simulation. This is like, we set up our town, we set up our people, we set up some history lists so we can track all that data. The next thing we're going to do is actually make our simulation loop. So for day in days. So for each day, we're going to start off with healthy. The amount of healthy people is going to be equal to 0, right? And this is just for tracking it. So the amount of sick people is going to be equal to 0. Same thing for recovered. And same thing for dead. So now we have all those numbers set up. Now we actually have to send our people, each one of our people is going to go to a building that day. Everybody's going to go to one building that day. A more advanced simulator might have like a probability that they go to a building, or they might go to multiple buildings, but in ours we're making it simple. Each person is going to go to one building in the town per day. So for person in people, just like that, and people is our list of people that we made. So for every person in the people, we're going to say that the persons, and remember up here in person, we gave them a variable called building. They have an attribute called their building. So we're going to say person.building, just like that, is equal to the list of our town, so the buildings in our town, randint, so a random integer between 0 and the length of the town minus 1, just like that. Okay? So now what we have is we have our town of buildings, we have our people. For every person in those people, it's going to pick a random building to send them to, and that's going to become their building that they went to that day. Nice. That's that whole loop, but we'll make another loop now. We're going to say for person in people, so the same loop as before, the same loop condition. We're going to say if the person, like that, dot status is equal to healthy. So if they are a healthy person, we have to count that. So healthy plus equals 1. So there's one healthy person added to our number of healthy people. But elif, the person dot status is equal to sick, just like that. Well, now we have to add a person to the sick list. So, or sorry, we have to add the number of sick people is plus equal 1. So we add 1 to the amount of people that are sick. And we're going to do the same thing for elif person dot status is equal to recovered, just like that. We're going to say recovered plus equals 1. And else, so if their status is something else, well, they're actually dead. So dead plus equals 1. Now there's one more thing we have to do here. If a person is sick, so when it's going through all the people, and it notices that a person is sick, that person has already had their building assigned. And so what we can do up here is in the building, we actually have an attribute called num6, so the number of sick people. So under here, under sick plus equals 1, we can say that the person that we're looking at dot building, right? And that building is a building object. So person dot building dot num6, so the amount of sick people in their building plus equals 1. We can add 1 to that. So now we know that there's one more sick person in that building because this person is sick. So now we can calculate the amount of sick people in one building. And that's that whole loop right there. So the next loop that we're going to make, and there's just 2 more loops, so bear with me. So the next loop we're going to make is, again, for person in people, just like that. If a person dot status, so if the person is sick, just like that, well, what do we check when a person is sick? Well, how long have they been sick? So we say, and we add another condition, person dot time sick is less than, let's say 15 days. Let's say the virus lasts for 15 days. So you're sick for 15 days. So if the person's time sick is less than 15 days, we're going to say that the person dot time sick plus equals 1. So in other words, if they're sick for 14 days, we add 1 day, and now they've been sick for 15 days. If we have 10 days that they've been sick, now it's 11 days that they've been sick. We have to add 1 day to how long they've been sick. But what if they've been sick for 15 days? So elif, the person dot status is equal to sick. So if they're sick, and the person dot time sick, so the amount of time they've been sick, is equal to 15, well, now we have a problem. They've been sick for 15 days. And now one of two things will happen. Either they will recover or they'll die. So what we want to do is we want to give it a probability. So there's a probability that the person will die or a probability that the person will recover. What we're going to do for this is say if randant, so a random number between 0 and 9, which is actually 10 numbers because it includes 0. So out of 10 numbers, if that number equals 4, so in other words a 10% chance, the person dot status is going to be equal to dead. So in other words, we make one random number, right? So the random number is between 0 and 9. And if that's equal to 4, so a 10% chance, now that person is dead. And that's pretty much it there. And then what we can say is else, if it's any of the other 90%, so if it's not that the person died, well now person.status is equal to recovered. Just like that, recovered. I think everything is good. Yep, okay. So now we have that done. That loop it should be done. No, there's one more thing we have to do here. We have to say that if a person.status is equal to healthy, so if that person is healthy, sorry about that, if the person is healthy, then they actually have a chance of infection that day, right? So the chance of infection is going to be equal to some percent. Now, how do we calculate that percent? Well, I'm going to do it kind of arbitrarily here. I'm going to say 0.0008. So in other words, 0.08%. So 0.08% times the amount of people that are sick that are also in their building. How do we get that? Well, we have person dot building already, and we also have dot num sick. So we actually know the amount of sick people in that person's building because their building has been updated up here to tell you how many sick people there are. So we can multiply the amount of sick people in the building by the probability that one of those people gets them sick. In this case, it's very low, 0.08%. So now we're going to have that be the chance of infection. And because we know the chance of infection, we can say if random, so a random number between 0 and 1, a random decimal, is less than the chance of infection, well now that means that the person is sick. So person.status is equal to sick, just like that. Nice. The last loop that we have to do here is for each building in the town, we have to take all the people out of that building. So at the end of the day, building.numSick is equal to 0. That's just at the end of the day. Nice. So the last thing we're going to do in this function besides the actual data plotting is that we are going to say that the healthy history, so that list that we made up here, we have to update all these lists with our new values from the simulation. So the healthy history is going to, we're going to say dot append, right? The amount of healthy people. And we are going to say that sick history dot append the number of sick people. All right? And then we say recovered history. So the recovered history is going to be equal to, sorry about that, recovered history dot append recovered, just like that. And finally, we are going to do dead history dot append dead. So the amount of dead people is appended as well. Okay, right on. So that is actually the whole simulation. Now we just want to show the data. And to show the data, I'm not going to program that out from scratch. I actually prepared a little, here we go. So this is some matplotlib code from what we imported earlier. I'm going to just you can pause it here if you want to copy this down, but just to explain it quickly, what we're pretty much doing here is we're saying that there's going to be a figure here and the axes of those figures. We have plt.subplot, so we're making 4 plots. We're going to plot all 4 of the things we were tracking, so healthy, sick, recovered, and dead. They're all going to share the x-axis because they're all over days, like the amount of days in the simulation, but they're not going to share y because they might have different scales of y values. So here we have the super title for the whole figure is going to be virus simulation. And then we have each of those plots that we're making. So we have the healthy people, the sick people, the recovered people, and the dead people. Last thing we are going to do here is say plt.show. So we can show that. And yeah, down at the bottom, we're pretty much almost done. We just have to run the simulation. And so to run the simulation, we are going to say simulate, because that's the name of our function. Now we need the number of buildings. So let's say there's 75 buildings, and there's 25,000 people in the town. In fact, instead of 25,000, we're going to say 24,975 healthy people, because there's 25,000 people in the town total. That's how many healthy there are, which means there's 25 sick people. And we're going to run the simulation for 100 days. And now we're totally ready, so I'm actually going to run this. And when I run this, it's going to go through and calculate that simulation, so all that information. And it's being calculated as we speak, so it's just going to take a second because there's, it's iterating over 25,000 people for 100 days, so you can imagine how many iterations it's actually running. But now it is complete. And so I'm actually just going to make that graph big, and I am going to pop it up here. So you're going to see, boom, there's our graph. So we have our virus simulation up here at the top. What we notice is that we have the healthy people on top, and you can see they started up at about 25,000, but then people started getting sick. And as people started getting sick, then people actually started getting sick quicker and quicker and quicker until about here. Then they started slowing down how sick they were getting. The reason for that is immunity, like herd immunity. What happened was so many people had either recovered or died around this point that it was slowing down the spread. Here you can see the amount of sick people. So people started getting sick, 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 sick. And this is that curve they're talking about when they talk about COVID-19. The curve goes up. Here's the peak of the curve when, almost 20,000 people are sick. And then less and less people are sick because more people are recovering and passing away. So here we go. That's the amount of sick people. For recovered people, you can see that, people start recovering about here when people start really getting sick. But the max speed of recovery and death, so the max rate of increase for recovery and death, happens about 15 days after the maximum amount of people get sick, because it makes sense, right? The most people were sick on this day, so 15 days later, if the most people got sick on this day, then the most people are recovering and passing away 15 days later. But yeah, this is our virus simulation. It's pretty simple. You can mess around with the parameters. You can change the different things in the function that we pass in. So just to show you that really quick, down here, again, let's say you want to try it with 100 buildings, or maybe you want to try it with 35,000 people. So you can change it like that. Again, I'm not going to run it again. I'm just showing you. You can change all these values. You can run the simulation for 300 days. You can start with 1 sick person. You can start with 100 sick people. It doesn't matter. we made a simulation function, and now you can use it to explore, when you change those numbers, what sort of effects does it have on the rate of spread of this virus that you've created in this simulation. So I hope you guys learned something, and I hope if you followed along all the way to the end that you are interested. Please rate, comment, and subscribe, like I said at the beginning of the video. And yeah, hit that notification bell so you're notified when I do stuff like this again. Again, thank you for watching, and I will see you guys in the next one. Peace, guys.